Okay, we want to now learn the derivatives for the 6 basic trig functions. So these are your 6, and you will eventually make a note card on this. So the derivative of the sine is the cosine function. The derivative of the tangent is secant squared. Derivative of the secant is secant tangent. Now, if you look at this, the 2 columns, notice that all of these on the right are the co-functions of these, and notice all of these derivatives have a negative sign. So if you know the co-function, you should be able to come up with the co-function derivative pretty easily. So the co-function of the tangent would be the cotangent. The derivative of the tangent is secant squared, so the derivative of the cotangent will be a negative, and then the co-function of secant squared would be cosecant squared. Same idea with secant. So if the derivative of the secant is secant tangent, then the co-function of cosecant is cosecant, so the derivative of that will be negative, and instead of secant tangent, notice the derivative is cosecant cotangent. So that's the way I try to remember it. Okay, so let's just practice taking the derivative with the trig functions. So the first one, I have to use a quotient rule because I have variables on the top and the bottom. So using the quotient rule, we take the derivative of the top, which is cosine of x, times the bottom, minus the derivative of the bottom. The derivative of the cosine is negative sine, so really this becomes a plus sign, times the top, which is another sign, all over denominator squared. Now we are going to practice simplifying the trig a little bit. So notice on the top I can go ahead and multiply it out. I have cosine plus cosine squared x plus sine squared x. And one of the identities that you learned last year is that sine squared plus cosine squared equals 1. So all of this becomes 1. So I have a cosine of x plus 1 really on the top. And then notice that factor you have on top and bottom. So really your final answer would look like this. Now, for a short answer, you would not have to simplify, but sometimes in multiple choice, you want to be able to simplify to match up the answer. Okay. The next one, number 2, you've got secant times cotangent. So we can use the product rule, secant times cotangent, but sometimes with the trig, it may be easier to clean things up first or simplify it, because maybe that'll make the function simpler to work with. So if you remember from pre-calc, secant is really 1 over cosine, cotangent is cosine over sine. So this function is really 1 over sine, which is the same as cosecant. That's much simpler to work with. And the derivative of the cosecant, it's a co-function, so it's negative. So it's going to be cosecant cotangent. Now, if you did the product rule, you would get the same answer, but then you would simplify a little bit and you would get to here also. Okay. Letter C, we learned that if there's a number in front, we just leave that number. Derivative of cotangent is negative cosecant squared. We just leave the 2. So this is my derivative. Again, sometimes, so letter D, you can use the quotient rule, but instead of doing that, let's rewrite it as 2 sine of x, and then the derivative becomes much easier. This is just 2 cosine of x. Okay, last 2, I'm asking for the first derivative as well as the second derivative. So your first derivative, derivative of sine is cosine. Second derivative, you just do it again. What's the derivative of cosine is negative sine. That 3 is just your constant multiple, so we just leave it. So there's my first and second. Last one here, the derivative of 2x squared is 4x. Derivative of secant is secant tangent. And we learned the derivative of e to the x is just e to the x. The 3 just stays. So there's my first derivative. Let's go ahead and do the second derivative. The derivative of 4x is 4. The 6 is going to stay in front of everything, but I do have to use a product rule on secant tangent. Now, if you want, let's try to see if it cleans up at all. So secant is 1 over cosine. Tangent is sine over cosine. So it doesn't look like it cleans up. So I'm just going to leave it like this and use my product rule. So derivative of secant would be secant tangent times the second, which is tangent again, so this becomes tangent squared, plus the derivative of the second, the derivative of the tangent is secant squared times the first, which is another secant, so this really becomes secant cubed, and the derivative of e to the x is still 3e to the x. And we're just going to leave our answer like this.